Hello, this is Mr. Collier, and today we're doing integration by parts. Okay, so integration by parts is, well, you can actually derive this from the product rule for differentiation. But this is what it says right here. So basically, if you have a function u, you let part of the function be u and let part of the function be dv dx. And then you can integrate this part and get v, and differentiate this part and get du. And then you have this integral equals uv minus the integral of v du. Sometimes we write like this. Okay, so when you want to look at a function that has two parts, one that you can easily differentiate and one that you can integrate, then you might be able to use integration by parts to figure out what the integral is. So in this case, we're going to let u be x, because if I differentiate x, it'll become 1. If I start integrating x, you'll get x squared and x cubed, and it'll just get bigger. So it's better to let this be x, and then it will disappear after we differentiate. Okay, and then we're going to let dv equal e to the x, and the integral of e to the x is just e to the x. So if I integrate, I get v, so v equals e to the x, and du equals just 1 dx. So that means this integral is equal to uv, so you just do u times v, so that's x e to the x, minus the integral of v du, so it's straight across here, so it's going to be just e to the x. So now it's a very simple integral. Get the e to the x minus, e to the x. So x e to the x minus e to the x plus c is the answer. You can check by differentiating this. If you differentiate this, you're going to get a e to the x and a minus e to the x. You're going to get this thing back. Okay, let's look at this example. So again, you want to let u equal this one here, because after you differentiate twice, the x will disappear. So we'll let u equals x squared, then du equals 2x dx. We'll let dv equals cosine x, and the integral of cosine x is sine x. So this becomes always going to be uv, so that's x squared sine x, minus the integral of v du. Right? V du is 2x sine x dx. Okay, so now we got to find the integral of this, and we use parts again. So we let u equal x, then du equals 1 dx, and dv equals sine x. So v equals negative cosine x is the integral of sine x. So we've got x squared sine x. I'm going to take that 2 outside. And then here we've got the uv minus integral v du. So the uv is negative cosine x dx. Negative cosine x times, sorry, uv, so x times that, so it's going to be negative x cosine x here, minus the integral of v du, so that's going to be negative cosine x dx. Okay, don't forget the brackets here, and watch out for the negatives. That's a common mistake with integration by parts. There's a lot of negatives flying around. Okay, so here we got negative 2 times negative, so that's negative, sorry, it's positive 2x cosine x. And then over here, the integral of cosine x is sine x. Now we've got negative times negative times negative, so that's going to be negative 2 sine x plus c is the final answer on that one. Next we got this this integral, and it looks like there's only one function here, so there's nothing to call u and dv. There's no way to separate this into two functions, but actually you can separate it into a function 1 times ln x dx. Okay, now if you look at ln x, obviously that's easy to differentiate, so you want to let u equal ln x, and then the dv equals 1 dx. Okay, so if I integrate that, I get x, and if I differentiate this one, I get 1 over x dx, so that's du. So this becomes uv, which is x ln x, minus the integral of v du, so that's just x times 1 over x dx. So that's x ln x minus the integral of 1 dx, so that is x ln x minus x plus c.